Hello everyone, welcome back to my channel. I am Deepak.R, studying in Sri Venkateswara College of Engineering from the Department of CSE Cybersecurity. Today, I am going to explain about my topic, Banker's algorithm for deadlock avoidance. Introduction to deadlocks and the need for deadlock avoidance. Deadlocks occur in a multitasking environment when two or more processes cannot proceed because each is waiting for other to release a resource. This can lead to a complete standstill, impact system performance and stability. To address this issue, deadlock avoidance mechanisms such as Banker's algorithm are employed to prevent deadlocks from occurring. What is the Banker's algorithm? The Banker's algorithm is a resource allocation and deadlock avoidance algorithm used in operating system to ensure the safe execution of processes. It is designed to avoid deadlock by considering the current state of available resources and the potential future request for those resources by processes. By maintaining a record of the maximum resources that each process may need, the total available resources, the banker's algorithm can make a decision on whether to grant a request for resources, ensuring that the system will remain in a safe state, free from deadlock, and now and in the future. How does the banker's algorithm work? Resource allocation and maximum time. The banker's algorithm works by considering the current state of the system and the maximum resources that a process may need to complete. It then checks against the available resources and the resources held by other processes to determine if the request can be granted immediately or if the process need to wait to avoid potential deadlock situations. Safe and unsafe states. It also keeps track of the safe sequence of resource allocations to ensure that no deadlock can occur. If a request would lead to an unsafe state, the banker's algorithm will deny the request to prevent deadlock. This careful management of resources ensures that the system can continue to function without getting stuck in a deadlock situation. Dynamic resource allocation. The algorithm dynamically allocates resources based on the needs of the processes and ensures that the system remains in a safe state. It does this by constantly checking the available resources, the process's maximum claim, and the resource currently held, allowing for flexible and efficient resource management while avoiding deadlock scenarios. Safety algorithm in Banker's algorithm. Definition. The safety algorithm is a key component of the Banker's algorithm used to determine if a system is in safe state or not by simulating the allocation of resources to processes. Process. It works by looking at the currently available resources and then finds an order to execute the processes such that they can complete without entering a deadlock situation. Responsibility. The safety algorithm ensures that the resources are allocated in a way that prevents deadlocks by carefully managing the requests and releases of the resources based on the maximum needs of the processes. Banker's algorithm example. Initial state. The bank starts with a set of available resources and the maximum demand of each process. This includes the total resources available and the maximum resources each process may request, illustrating the current state of the system. Resource request. A process requests a set of resources. This indicates that the process needs certain resources to continue its execution. The request specifies the number of resources of each type required by the process. Resource allocation. The banker's algorithm checks if the requested resources can be allocated immediately or if the process needs to wait. It simulates the allocation of resources to see if it's safe to grant the request without causing a deadlock. Advantages and disadvantages of Banker's algorithm. Advantages. The Banker's algorithm ensures that the system is in a safe state, preventing deadlocks from occurring. It allows efficient allocation of resources, ensuring that no process will have to wait indefinitely. Additionally, it helps in maximizing resource utilization and ensures that resource allocation is done in a safe manner. Disadvantages. One of the drawbacks of the banker's algorithm is that it requires maximum resource needs to be known in advance, which may not always be feasible in real-world scenarios. It can also lead to underutilization of resources as processes may waiting for resources that are not immediately needed. Moreover, the algorithm does not take into account the priority of the processes, which can impact systems performance. Real-world applications of Banker's algorithm. Banking systems. The Banker's algorithm it is widely used in banking systems to prevent deadlocks in the allocation of resources. In this context, the resources can represent the different assets and services provided by the bank, such as cash, loan approvals, or customer service representatives. Manufacturing processes. In manufacturing, the banker's algorithm is applied to manage the allocation of resources such as raw materials, machinery, and labor to avoid deadlock situations. It ensures that the production of processes run efficiently without encountering resource allocation conflicts. Software development. Software development teams utilize the banker's algorithm to allocate resources like memory, CPU, and processing and I/O operations. This prevents deadlock scenarios in multi-threaded applications and ensures the efficient utilization of system resources. Conclusion and summary. As we conclude our exploration of the banker's algorithm, it is essential to reiterate the significance of this vital deadlock avoidance strategy. Throughout this presentation, we have delved into the intricacies of the banker's algorithm, comprehensively understanding its underlying principles and operational mechanics. From the resource allocation graph to the safety algorithm and real-world applications, we have dissected each component to emphasize its critical role in managing system resources and mitigating the risks of deadlock scenarios. By embracing the banker's algorithm, organizations can proactively address the potential deadlock situations, ensuring smoother operations and resource utilization. Thank you for watching the video.